Hey, hello, data lovers, and welcome to another I Love Data Fridays podcast. This podcast is from Volume 3 of I Love Data Fridays from February 10th of 2017. And this is question number 2, where the question was about the correlation between the Ohio Word Test and the Slosson Oral Reading Test, Revision 3. So who's talking data to you today? Well, of course, you've got me, Jeff Breimer-Bashore, Director of IT and Operations. And also joining me on this podcast is our system analyst, Richard Terry. Richard, how's it going?
Going pretty good. How about you?
All right. You ready to talk a little data?
Of course I am.
All right. Good answer. All right. All right. So, ladies and gentlemen, let's get to the question number 2, sent in by one of our teacher leaders. It says, is there a correlation between the scores on the Ohio Word Test and the scores on the Slosson SORT R? The SORT just stands for Slosson Oral Reading Test. So there we go. Nice short question. So let's talk a little data. I think the first thing we'll try to answer is what is correlation? And then Rich and I, we are going to actually calculate the correlation coefficients between the Ohio Word Test and the Slosson Oral Reading Test. And it's going to be a little competition, Jeff versus Rich. Well, not really. We're not really competing against each other, but I'll explain a little bit about that later. So first, let me talk about what is a correlation. And simply, a correlation is a mutual relationship or connection between two or more things. All right, so I stole that right from the dictionary. The teacher leader is asking, are the Slosson and the Ohio Word Test related in somehow? Is there some sort of relationship between them? And I think, there probably is, because if we think about it, both of these tests are word tests. So on the Ohio Word Test, children are asked to read a preset list of 20 high-frequency words, and there's 3 different lists that teacher can choose from. And the Slosson Oral Reading Test is structured in a way that a teacher asks a child to keep reading. They start with easy words, and the child keeps reading words until they miss a certain number of words, and then however many words they read correctly, that is their score. So we both kind of have word tests here. So there probably is some sort of relationship between it. But what we try to find out with correlations, we're going to try to answer, as the scores on the Ohio Word Test go up, what happens to the scores on the Slosson Oral Reading Test? Do they go up? Do they go down? Do they do nothing at all? All right, so that's the relationship we're trying to test. Now, we do this by computing what's called a correlation coefficient. All right, and this little statistical function computes a number that will lie between -1 and 1. And this result tells us 2 things, or the number that we get back tells us 2 things. First, it tells us what type of correlation it has, whether it's a positive or a negative correlation, and I'll explain what those are in a second. And then it tells us how strong the relationship is, whether we have a really weak relationship or a strong relationship or some kind of, mild relationship or moderate relationship between our 2 tests there. Now, I'm going to pop over to a website here because I love going to my friend, the internet, and always looking up stuff on the internet. So I went here to mathisfun.com because it is fun, folks, because we love data. And there's a page on mathisfun.com that is specifically about correlations. And so let me first talk about what a positive correlation is. So remember, when we compute it, it's going to give us a result between 1 and -1. So if that result is positive, it means that the values increase together. So if we get a positive value, it means that as the Ohio Word Test increases, so does the Slosson Oral Reading Test. If that number is negative, it means that it has a negative correlation, and it means as the Ohio Word Test decreases, the other increases. So it does the opposite. Okay? So now we look at, if we were to plot, say, our data on some charts, and sometimes you can actually visually see how the correlation is going to play out before you even compute it. Now, these are just some simple examples. These aren't any examples that Rich and I have used today. But what they're showing over here on the left is an example of some data that has a perfectly positive correlation that, you know, you can essentially draw a nice big straight line through all of those dots. And it means that these points change, that this data, as one changes down here, the other changes in lockstep with the other data. As we move this way, we see we get examples of where the relationship is less strong. So for example, this data their sample data has a 0.9 relationship. Notice how our dots now aren't in a nice straight line. We could still draw a line of best fit through there, and that would tell us that we still have a nice relationship. There's a weaker relationship. There probably a line exists in there somewhere. Here we have no correlation example, an example of no correlation or relationship at all. And then over on the right-hand side, here's when we have our negative relationship. And as we get more negative, that perfect negative correlation gets stronger. Once again, we could draw lines of best fit through all of those. Okay, so now just to review, when we do this example, our values are going to range from -1 to 1. If our correlation is positive between 0 and 1, it means we have a positive relationship. If it's less than 0, between 0 and -1, it means we have a negative correlation. Now, what this number we get, it tells us how good the relation is, the correlation is, but not how steep the line is. So it doesn't tell us how steep this, if we were to draw a line of best fit through these, it doesn't tell us how steep it is. It just tells us how good our relationship is. All right. That's that. Let me switch slides here. See, math was fun, folks. I know you thought that. All right, so now it's time for the battle royale, the battle of the correlation coefficients. So Rich and we are going to compute the correlation coefficients, but we're going to use different methods, mostly different software to do it. And if we do it right, I think we should come out with the same results. So do the results come out the same? All right, so here is the methodology we are going to follow. We are going to use random sample data from the 2015-16 school year. Then each of us is going to combine the fall scores, Slosson fall scores and Ohio word test fall scores. We're going to combine them with the mid-year Ohio word test and Slosson scores, and with the year-end Slosson and Ohio word test scores into one single data set that we will give then to our statistical software to analyze. All right, we'll compute the correlation coefficients using this combined data set. Now, we're using some different tools. Well, we're using similar and different. Rich is going to start out. He is going to use our T-SQL, that stands for Transact SQL SQL Management Tool. He's going to pull some data from our database. He's going to create that single combined data set to be analyzed inside of the T-SQL there, do the hard work to get that, and then he's going to copy and paste this single data set into Excel and compute the correlation coefficients. On the other hand, I am going to use our T-SQL Management Studio to pull data from the database, but I'm going to use a statistical program that is called R, just the single letter R, and I will use that to create our single data set to be analyzed and then compute coefficients. All right, I'm going to let Rich go first, which means we need to switch screens. All right, Rich, I can see you.
Let me explain a little bit of what's going on here. So this first section here, this is us pulling the fall data. So you'll see here we're pulling data for fall Slosson and also for fall Ohio word test from our student database. We're only using data that's school year is 2015 to 2016, which is what that means there. This here means that we're only pulling random sample students, and this means basically that we're pulling data when there's basically no blanks in those sections. And we're doing that for, like I said, fall. And we've got mid-year Slosson and mid-year Ohio word test, year-end Slosson, year-end Ohio word test, because we call that S. And then down here, we're putting all three of them together, and we're getting the results here. So what we're going to do is we're going to take these results, we're going to copy them, we're going to go into Excel. Now that we've got the data here in Excel, I'm going to go ahead and do the correlation. And the way that we do that is through our data analysis application. So we go ahead and tell it correlation. It's going to ask us what data do we want to use. I'm going to tell it this data here in columns A and column B. I'm going to tell it I want to make sure that the label's in the first row, or else it's going to try and use that as part of its data analysis, and those are words and they don't really have a correlation. And then we're going to tell it where exactly we want it to go, and I'm going to tell it where we want it to go there.
Yeah, it's where it's going to spit out its results.
Yeah, hit OK, and it's going to show us these numbers here.
So the way that the correlation, so this may not make sense at first look, people, and what's important is the box that Rich is coloring right now is the line where it's doing the Slosson to the Ohio word test, and it has a correlation coefficient of 0.737922. Excel, and you will see it also in mine in R, whenever it computes the correlation coefficients, it goes through and tries to compute the relationship between the Ohio word test and the Ohio word test, and then between the Slosson and the Slosson. And of course, there's a perfect relationship, which is being indicated by that number one, those number ones. But what's important is that 0.73922. Now, I'm going to get my handy dandy 100 questions and answers about statistics book. This is a book by Neil J. Salkind, and I'm looking in his question 46 on page 94 of this book. So what does that 0.73922 tell us? Well, anything that has a coefficient between 0.6 to 0.8 is a strong relationship. So Rich's computation is showing that we have a strong relationship between the Ohio word test and the Slosson. All right, thank you, Rich. All right, let's switch screens here, and let me explain what I've done. So initially what I've done is I have gone through and selected fall Slosson, fall Ohio word test, mid-year Slosson, mid-year Ohio word test, year-end Slosson, and mid-year Ohio word test from our database. I'm only doing it for the 2015-16 school year like Rich did. I am getting only random sample students. That gives me the results down below, my initial data set that I'm going to work with. Now, I went ahead and I saved this into a file on our computers here because my next program, R, is going to read those data from that file. So let me explain. We're going to look over on this side of the screen here. Now, Rich, I'm going to warn you, I already out-nerded you on this. I purposely... Oh, yeah, because, you know, can't be out-nerded on a video and a podcast. Anyways, so I first line here in my R script, I've loaded my data from my file right here. Then I am going to go through and I ask R to give me all the fall students who have both a fall Ohio word test and a fall Slosson. Then I ask it to give me all the students with a mid-year Ohio word test and a mid-year Slosson. Then I ask it to give me all the students with both year-end Ohio word test and year-end Slosson. These series of lines, I prepare my final data set, and then these two lines, I join all my results together into one data set, and then I compute it, the correlation right here, and then Rich, you're going to see that a chart and graph is going to pop up with a trend line in it, and I'm going to relate it back to the Math is Fun website. All right, so let me run my script. There's my chart, but let me slide it off to the side real quick. Ladies and gentlemen, what we're really concentrating on right here are my results. Here are my correlation coefficient results. Once again, you'll notice it's given in sort of that two-row, two-column format like we saw in Rich's, but what is important is this correlation right here, 0.739215. And Rich, that's the same as yours, but I think yours is rounded up because you got 737926.
No, I got 737922.
Oh, 22, yes. Yeah, that 5 gets rounded up, that 1 gets rounded. Yeah, so Rich and I, because of some roundings, we got a minorly different answer, but if you round mine to the next spot, I get a same answer as Rich. So now it's telling us once again that we have a strong, remember, it's a strong positive correlation And if we remember back to our Math is Fun video or webpage here, that on the right here, our positive, or left here, our positive correlations, if we drew a line of best fit through our data, that, we would have this line that goes up from the left to the right, starting from the bottom left going up to the top right. That implies that we have that strong relationship. And ladies and gentlemen, don't try to interpret the dots on here. What's important is that our line, we plotted a line of best fit, is that it's showing that our correlation is doing that, going from the bottom left up to the right. So it just reconfirms already what the number is telling us. So there we have it, ladies and gentlemen, our preliminary results here, that there is a correlation coefficient of 0.739215 between the Ohio word test and the Slosson. And as I say, our preliminary results here show that it is a strong relationship. Now, you're probably saying, well, Jeff, you keep using the words preliminary results. Why are you saying preliminary results? Well, I hesitate to say that this is the official results, because when it comes to reporting statistics and testing things like this, it's a very careful process. You always, it's not like we have submitted this to a journal for peer review or anything. I have certainly asked for help in designing the methodology, so I think we can get as reliable answer as we can get. All right, well, ladies and gentlemen, I want to say thank you for joining us for another I Love Data Fridays podcast. Rich, thank you for your assistance today.
No problem.
All right, and ladies and gentlemen, we'll talk data to you later.